now now our question number 5 is about free body diagram. Here in this question we have to calculate free body diagram for all type of members for this type of trusses. Here we have to calculate free body diagram for this member, GE member, and BF member, and also for BD and EC member. Also we have to calculate free body diagram. So first of all, what is free body diagram? Free body diagram is actually the is a graphical representation and it is used to visualize the applied forces and moments and resulting reactions of any kind of body. This type of graphical representation actually called as free body diagram of any body or a structure or a member. Now we have to calculate this free body diagram for these members. So let's start our question. Free body diagram for the GE member will be look like this. When we want or need a free body diagram for any member, or you can say for a member GE, then only we have to draw that member only with its applied loading or a resistive loading. As I have drawn this member with its all loading acting on it, you can see I have drawn EY, EX and FB forces. As we know that member EC is resisting or pulling, member EC is pulling or resisting, or some kind of resistive force is there which is acting on member GE. So in order to draw free body diagram for this GE member, we have to mention these forces here. As we know that here is the pin joint. Due to pin joint, here is two type of forces. One is vertical, second is horizontal force. And due to this member, BF member, there is also a force at some angle at distance 1 meter from G point. So I have drawn GE member for free body diagram. First of all, these forces is unknown. We have to calculate these forces by using the equation of equilibriums. As we know that to make any structure stable or any member stable, these three equations should be fulfilled. So first of all, we are calculating summation moment about B point, sum of all moments about E points should be equal to 0. Then here we assume anti-clockwise moment taking as positive and counterclockwise anti-clockwise taking as negative moment. Here at G point, load is acting downward of 125 kg. To convert kg into Newton, we have to multiply this by 9.8, which is already done. So here we have to calculate moment about E point. So E point is spin, then rotate it. This load, due to this load at this point, moment will be created as force downward acting create a moment in a anti-clockwise direction taking as positive. So force into perpendicular distance produce a moment. This produce a moment in anti-clockwise direction due to, and then this is taken as positive. Then due to this loading, this is also create also moment. By resolving this force into components. One is vertical, second is horizontal component. So what is angle between them? We know perpendicular and horizontal distance, so we can calculate this angle easily. Tan inverse perpendicular over base. Here perpendicular will be 3 and base will be 2, so theta will be equal to, here is a mistake, base will be 1. This is 2 minus 1 makes base equal to 1 meter and perpendicular equal to 3 meter. After putting these values, we get theta 71.56 degrees. So by putting these, we get a vertical component also. Here vertical components act at this point. It will rotate about E in a clockwise manner, and clockwise taken as negative. So here we can put vertical component sine into angle 71 degrees into perpendicular distance. Perpendicular distance is 2 meter up to point E, and horizontal component will not make any kind of moment about E, as horizontal component will act in this direction and it has not a perpendicular distance from point A. So perpendicular distance for horizontal component will be 0, so horizontal component will not make any moment about point A. So by putting these values, we can easily calculate force in FB member. FB member, Newton, to convert it into kilonewton, I have to divide it by 1000 to make it kilonewton. So we easily calculate FB force. Now after this second equation of equilibrium, now taking all the vertical forces, summation of all the vertical forces equal to 0, should be 0. Assume upward force is taken as positive and downward force taken as negative sign. So upward force is this vertical component of FB is the vertical force, FB into sine into angle. After this is a downward force taken as negative, and EY is also negative because it is acting in downward direction. It makes it equal to 0. Then by solving this equation we can easily calculate EY. After that, makes all the horizontal forces, summation of all the horizontal forces equal to 0. Then after this is the horizontal force, and assume uh, horizontal force in a rightward direction taken as positive, in leftward direction taken as negative. So EY is moving in rightward direction, so EY is taken as positive. After this, horizontal component of this FB force taken as with negative sign because it is moving in out left side direction with cos angle. By solving this equation we can easily calculate EX. So free body diagram of GE member easily made by finding these unknown forces by using the equilibrium equations. Now we have calculated free body diagram for GE member. After this we will move toward the BE member, after this BD member, and then toward the ultimately toward the member EC. These three members is remaining. So let's do. Now we want to make a free body diagram for EC member. By now we have to draw only this member with its all type of loadings, resistive loading acting at this point. So EC member will look like this. Horizontal member and vertical force should be there as pin joint is there. At C point there is also a two component of the forces, one is vertical, second is horizontal. Free body diagram for EC member look like this. Here is the EX force and EY force which we have calculated earlier in GE member. So this is the free body diagram. All the forces which are going to act at EC member will be displayed here. Here FBD member is also connected with EC member, so this is also create some type of force, exert some type of force at that point in EC member. So by applying these equilibrium equation we can easily calculate these unknown forces as we calculated earlier. So taking sum of all moments about C point should be equal to 0, and anti-clockwise taking as positive and clockwise taken as negative. So this force will not create any moment about the C point as it has not any perpendicular distance up to C point, so this will not create any moment. EC will rather create a moment about C point. This force into perpendicular distance will create a moment of a clockwise. Create a clockwise as it is negative. Negative shows that its direction is in opposite direction. So it create a anti-clockwise moment into perpendicular distance which taken as positive, and this has a horizontal and vertical component, and vertical component act in this way, and this has also not has any perpendicular distance up to C point, so this will not create any moment taken as 0, and horizontal component acting as this in this direction, and here angle will be 45 degree. So by converting into horizontal component and taken as perpendicular distance 1, we can easily calculate moment about C point from of this force is horizontal force. By solving this equation we can easily calculate force in BD member. This is in Newton. By converting it divided by 1000 we can easily convert it into kilonewton. After this, taking all the vertical forces equal to 0, assume upward forces taken as positive. So here what are the upward forces? So this is vertical force in upward direction, so taken as positive, and this will have a vertical component in upward direction, so this is also taken as positive, but here is 45 angle with this vertical component member 45 angle. So to convert it into vertical member, this will sine into 45 degree. This will make a horizontal component for this force. To convert it into vertical component, FBD should be multiplied with cos into 45 degree, as this force makes angle with this vertical member. So converting this to make this member, this force, we have to multiply with cos 45. So this is the vertical component of force BD taken as positive as it is in upward direction, and Cy is, as we have assumed, this in downward direction. So taken as negative, we can write it here or it here. By moving it from here to here, the sign will make equal to positive. By taking all the horizontal forces equal to 0, then let us assume rightward force is taken as positive and leftward taken as negative. So here Ex is rightward or leftward. If it is negative, it means it is leftward direction and taken as positive. So here negative in leftward direction, horizontal component, and horizontal component for the FBD force is equal, then Cx is also a horizontal component which moving in leftward direction, so taken as negative. By solving this equation, we can easily calculate horizontal component at C point, and after dividing it by 1000, we can easily get Cx value in kilonewton. Now we have drawn free body diagram for GE member and EC member. So similarly, we can also draw free body diagram for DB member and BF member also similarly. Let's take BD member as a free body diagram. Let's BD will be like this, and at this pin joint there is a one force in this direction known as F B F. ठीक हो गया? And one force is in this direction known as FBD, which is already calculated in EC member. I have drawn BD member. This is a force which is acting in BF direction, BF member, and this is force which already calculated in EC member previously. So here in this free body diagram of BD member, only unknown force is FBF. So to calculate this force, we can easily use any equation of equilibrium to find this unknown. First of all, we have to convert this force into its component. One is vertical component, second is horizontal component. The angle will be 71.56 degree in this direction. So horizontal force will be force in BF member into cos into 71 degree into 56 degree. This will make a horizontal force. By putting cos replacing cos equal to into sine, we can easily get vertical component of FB force. So equating it equal to 0. Now taking all the vertical forces equal to 0, as we take it equal to 0, then vertical forces taken as positive and downward forces taken as negative. One is this vertical force and second is component. One is horizontal component of FBD and second is vertical component. The vertical component will be put here in this equation. Here FBD 45 degree will this angle. So to convert this force into vertical component, we should multiply this force by cos into 45 degree. So this is vertical component for BD, and for this we have to multiply it sine into degree like this. These both forces are in upward direction, so taken as positive. Here we can easily, by solving this equation, you can easily calculate BF force taken which is in negative direction. So our assumption is wrong. Negative shows that the direction of BF force will be opposite. In opposite direction means in this direction. So Newton will divide by 1000 to make it equal to kilonewton. So free body diagram for BD member is also drawn. Free body diagram for the BF member we can easily draw. All the forces is known in BF member. So this is the free body diagram for the member BF. So all the free body diagrams for the all members is discussed.